Listen, it's Christoph here with another weekly update. If you hear any background noise, it's my roommates. I'm sorry about that, but I just wanted to give you a quick update about what I've been working on this weekend, and that's compiling. If you want just the short summary of it, I have a file here called foo.ys, and basically, if I run the code, it goes from this string interpretation of the file, and it gets compiled all the way down to bytecode, and then it's interpreted. So I got that working. I just want to give you a quick kind of overview on how that works if you're interested. So I pass it a file name when I actually run the code. So I run a file, and then from running a file, I interpret it, and then first step of interpreting is compiling it. And I pretty much wrote this entire file this weekend, basically just a bunch of code for compiling my string. I have different chunks, and the opcodes will be stored in the chunks. I used the scanner from last week, and I also wrote a parser this week. It's a single pass parser, so I'm looking at one token at a time and then turning it into doing the code generation, which will turn into bytecode. The kind of the crux of this algorithm is the advance. Let me find that for you. Advance. Yeah, it's this one right here. Basically, I take each token one at a time. I have a current token and I have a previous token, and I iterate through all my tokens. And if I don't have an error, that means I'm doing something right, and I turn it into an opcode. So yeah, I need to clean up the code a little bit, but another interesting thing that I did in the code is there's just it's kind of over-engineered right now, but that's because I'm going to build from it. The book basically had a function table, and they have a function table because they have the tokens here, so token left paren, token right paren, etc. And then there's the way it parses is there's a prefix and there's an infix. So each token is mapped to something called a parse rule that has function pointers. So this grouping here is a function, for example, and it basically defines how the expression should be parsed, meaning I can add different tokens and add different functions how I want, which is really convenient. There's different types of expressions right now. So there's grouping, for example, and there's also unary and binary, and there's also number. Each one of these is treated differently. It was tricky working in Rust because you have to worry about lifetimes and all that other stuff. But yeah, basically, I do have this very basic expression compiling right now. I actually tried it with a more complicated equation. It didn't work, but I need to start writing tests to make sure it works as intended.